Hello, welcome and lovely greetings to all of you. The backdrop must be clear. We are here for the solution of the question paper that had been asked in the 2nd September 2020 JEE Main. And I am here to take the morning shift. Let us begin. The first question is from electrostatics, a little bit of kinematics and a little bit of mathematics thereafter. And look at the question. This is the regular coordinate system. Here is the origin. An electric field is downward. And a positive charge has been projected rightwards with a velocity v0. Now after that, what it says is that we need to find the equation of path of the charge in the region x greater than d. And where is d? Of course, this particular line. So we need to see what is the path of the charged particle outside this region, and we need to formulate the equation for that. Let's see something very similar to the projectile computation, and let me just first pick up all the variables. So here is the acceleration, and the value of acceleration would of course be QE by m. Now let's see how would the particle move within this zone. Of course, it will move in a parabolic trajectory, velocity perpendicular to uniform acceleration. And the big question is thereafter what? Thereafter, since there is no acceleration which will change or deflect the velocity, so therefore the path has to be a straight line. So starting from here, the path is going to be a straight line. So we need to find the equation of this straight line. So what are the parameters required? Let me first calculate the magnitude of this particular length, which is y0. For that, what I can do is that, let's see what is the time taken by this particle to reach here. The time taken is of course equals to d divided by v0. The x direction is going to help us. And now, right at this particular point, you could see, if I see along y direction, the value of y0, that is going to be equals to 1/2 of acceleration a multiplied by t square. So the first job is done. We've calculated y0. And after that, we need to calculate what will be the slope of this straight line. And to do that, what I am going to do is, let me just calculate the angle here, and I'll be showing in this way. Here, this is the case, and here, this is the case. So let's go in terms of magnitude. So this will be the magnitude of Vy, and this will be the magnitude of Vx, this. And let's say this angle, which is theta. So here, I'll be getting something like this. The value of tan theta will be equals to magnitude of Vy divided by magnitude of Vx. Alright, so we have calculated tan theta as well. And after that, to calculate Vy will not be a trouble, because the value of Vy in terms of magnitude is going to be the acceleration along y direction multiplied by time t, and t we can place it from there. So everything is done. We have calculated y0, we have calculated this, and all I require is I need to put the equation of this straight line, and that can be easily done. We can do this by something like this. Y minus of y1 is equal to m into x minus of x1. All I need is that I need to fill up, and this particular value is of course x equals to d, and the value of y coordinate will be minus y0. So yes, let's see, this is going to be y plus of y0, and how much will be the slope? Of course minus of tan theta, the value of tan theta is there, into x minus of d. And when you solve this, you would be getting option number 3 as the correct one. So that was about question number 1. Now let's go to the second question. Now with a little bit of computation in the first, the second one is going to give you a little bit of respite. It's from electromagnetic wave. And you remember, this is the topic which is present only in JEE Main syllabus. And experience says that those topics having exclusive presence only in JEE Mains are one of the very favorite stuff. So this message would be helpful for the future aspirant. The question is very straightforward. The frequency has been given, energy density is there. We need to calculate the amplitude of the magnetic field. So here the energy density expression is equal to B naught square divided by 2 mu naught. And the value of mu naught is 4 pi into 10 raised to the power minus 7. The energy density is given. So not much of hassle in calculation. You'll get option number 2 as the correct one. Now let's say question number 3. Question number 3, YDSC, wave optics, one of the favorite spots of the examination. Now let's see here the regular interference pattern. There are lots of things given, so let me just write it in terms of variable, where we know the symbols have the usual meaning. Now let's say the two slits are 1 millimeter apart, so small d is given. I think that will be an easier way. The wavelength is also given. And the distance between the screen and slits, we generally represent it by capital D, isn't it? And apart from that, it says there is a bright fringe which is observed on a screen at a distance this much from the central bright fringe. So we don't know which order bright fringe, but there is a bright fringe at a distance y. Now we need to calculate the path difference between the two waves. Now this, comes out to be a straight formula based question. Y equals to d by d into delta x is the starting formula in interference, isn't it? YDSC. So that value, now say y is given, capital D is given, small d is given, delta x, a little bit of calculation, option number 1. So for this question, the question number 3, option number 1 would be the correct one. Let's go for the fourth.